everyone, welcome back to WsCube. In our today's session, we will be talking about bitwise operators. Now, guys, let's first understand what are bitwise operators.
Also, if you want to become a successful data analyst and you want to learn from our industrial experts, then you may call on the number given below, or you can also click on the link given in our description. Not just that, with our every batch, you will be getting 2 demo classes for free. So let's get started, guys.
Bitwise operators allows us to deal with the binary numbers. They allow us to compare the binary numbers basically. So there are 5 types of bitwise operator that we will be discussing about in this whole session. Our first is AND operator, second is OR operator, third is Exort operator, fourth one is zero fill left shift operator, and fifth one is zero fill right shift operator. Now let's understand what is AND operator. AND operator works like the AND gate over here, which gives the binary result of two zeros as 0, 1 0 as 0, 1 0 1 as also 0, but when it's 1 1, when there is a 1 1 in a binary number, it gives us 1. Let's guys, first of all, let's understand binary numbers to understand this method over here. So guys, first of all, talking about binary numbers, we all know there are two binary numbers, 1 and 0, where 0 indicates off and 1 indicates on. Correct. To find a binary number of any decimal number, we have a very simple method. We have a very simple formula over here. We will see what this formula is. For example, we have a binary number 8 over here. What we will do, we will keep taking an LCM over here with 2. Why with 2? Because binary itself means 2. That's why every time we will be taking an LCM from 2. Okay. So I'll create a small table like this. 2 when 8 when divided by 2 gives us 4 and the remainder is 0. Again, I'll write 2 over here, that 4 when divided by 2 gives us the remainder 0, and here also we will be writing 2. Again, I'll be writing 2 over here. 2 when divided by 2 gives us the remainder 0 and gives us the output 1. So we have 0, 0, 0, 1 over here. This 1 will also come back to here. Now about binary number, that is one interesting thing, that we count the binary numbers from bottom to top. So we will not be writing 0, 0, 0, 1 as 8. This will be wrong. We will be writing 1, 0, 0, 0 is equals to 8. That means it goes from all the way downside to up. This is how we find a binary number of any number. So I'll be considering another example over here, that is 15. Again, I'll be creating this table. I'll be writing 2 over here. Okay, 7 times 2 is 14 and remainder is 1 over here. Again, I'll write 2 over here. 3 times 2 is 6 and the remainder is 1 over here. Again, I'll write 2 over here. Times 1, remainder is 1, and here we get the output as 1, 1, 1, 1, which is our 15. So the binary number for 15 would be 1, 1, 1, 1. Now this is a simple method of finding a binary number. But what if there is a huge number? For huge number, you guys don't have to struggle much. All you need to do is when you go to Python's PyCharm. So suppose if you want to find a binary of any number, let's say I'll be finding the binary of 15 over here again. All I need to do is print bin, short form for binary, and whose binary I want to find. I want to find 15's binary. So it will give me an output over here with the prefix added to it, that would be 0b. So 0b 1, 1, 1, 1. So as we also calculated, it gave us 1, 1, 1, 1, and here also it is 1, 1, 1, 1. So if you want to find the binary of any number over here, let's say if I write it for 150, it gives me 0b 100 10110. This is how by this method you can find a binary of any number. You don't have to struggle much. But now you know what is the method also and how you can do it on Python as well. Similarly, if you want to reverse it, like till now what we were doing, we were converting the decimal numbers to binary. Now what if we want to convert binary number to decimal? For that also we have a very simple method over here. Let's have a look. So here I'll be writing conversion of binary to decimal numbers. Okay, so converting binary to decimal number is very simple. We'll start with 1. 1 when multiplied by 2 gives us 2. 2 when multiplied by 2 gives us 4. Why I'm multiplying it by 2 every time? Because we are finding it for the binary number, and binary, the word binary itself means 2. So every time we will be multiplying it by 2. Next is 8. 8 times 2 is 16. 16 times 2 is 32. 30 times 2 is 64. Let's consider it till here. Now suppose we have any binary over here. Let's say I have a binary 1, 1, 1, 0. Okay, I have this binary. I want to convert it to decimal. All I need to do is I'll start putting this below them. So 0 goes over here, 1 comes over here, 1 comes over here, and 1 comes over here. So what I will be doing, I'll be writing 8 multiplied by 1 as 8 over here, 4 multiplied by 1 as 4 over here, 2 multiplied by 1 as 2 over here, and 1 multiplied by 0 as 0 over here. So 4 plus 8 plus 2 will give us 14, and this will be the 1110 will be our binary for 14. And if you want to check, you can go and check with the help of the bin method as well to what is the binary of 1110, and you will get the output over there like this. Okay, so this is how we can convert binary to decimals and decimals to binary as well, right? Now let's understand with the AND method that how AND method works over here in bitwise operator. So how AND method works over here, that whenever there is a binary, let's take example, I have one binary over here that is 1010, that is the binary of number 10, and I am taking another binary over here that is binary of 8, which will be 1000. Okay, I know this already, but you can also find it with the help of the bin method as well. Now, what I will be doing, I will be comparing it over here. So it says that 0 0 operation gives us a 0. It will give us a 0. 1 0 also gives us a 0. It says 0 0 again gives us a 0, and 1 1 gives us a 1. So when we will apply the AND method on these two binary strings, it will give us 1000, which is the binary number of 8. Let's see with the help of the example in Python as well. So I'm considering a case of two variables over here. A is equals to 10 and B is equals to 8. Now what I will be doing, I will be performing this AND operation over here. So for that, for writing AND, all you need to do is put an ampersand between A and B. So if I print A ampersand B, let's run and see what we get. We get 8 over here, and if you want to see it in the format of a binary, like if you want to understand in the format of binary, we did it in our so as expected, we get 8 over here, which is correct, that when we will apply the function of AND on the binaries of A and B, we will receive 8 over here. Okay, now let's move ahead to our next operator, that is OR operator. Let's see what OR operator does. So guys, here our OR operator says that OR operator is represented by a straight line over here. Okay. Now here our OR operator says that whenever there is a 0 and 0, it gives us 0. Whenever there is 1 and 0, it gives us 1. Whenever there is 0 and 1, it also gives us 1. And whenever there is 1 and 1, it also gives us 1. So only in the condition of 0 and 0, it gives us 0, but otherwise in all the other condition, it gives us 1. Let's solve a small problem related to this. I'm considering the same example over here. Let's say I'll be writing 1010, which is the binary of 10, and I'll be writing 1 triple 0 over here, which is the binary of our number 8. So now if we'll apply the OR operation on this, so 0 0 will give us 0, as we have seen in the first line. 1 0 will give us 1. 0 0 again will give us 0, and 1 1 will give us 1. So when we apply an OR operator on the binaries of 10 and 8, we will receive 10. Let's have a look. Let's solve it in Python and let's see how it can be done. So here guys, I'm considering the same examples, that A is equals to 10, B is equals to 8. And for applying the OR operator over here, all I need to do is put a straight line in between of A and B. And if I run it, it gives us 10. So that means the method that we have learned, that is correct. And this is how it works, that when there is a binary of 10 and binary of 8, when we apply OR method to it, it will give us 10 in return. Moving to our next operator that we have in Bitwise, that is our Exort operator. Let's see how the Exort table looks like. So here our Exort operator is represented by an upward arrow. And how our Exort operator works on our binaries, let's see. So whenever there is a 0 and 0, it gives us 0. Whenever there is 1 and 0, it gives us 1. Whenever there is a 0 and 1, that means whenever there are opposites, it gives us again 1. It doesn't matter if 1 is coming first or 0 is coming first. Whenever there are opposites, it gives us 1. And whenever there is a similar numbers, XOR gives us 0. So even if it is 1 and 1 over here, it still gives us 0. So applying the same method on 10 and 8, let's see what happens. So if I write 1010 over here and 1 triple 0 over here, 0 0, so they are same, that's why it gives us 0. 1 0 gives us 1, 0 0 again gives us 0, and 1 1 gives us again 0. So it should give us 2 over here. 1 0 0 1 0 will be for 2. So it should give us our decimal number 2 over here. Let's try it on Python and let's see if our method is correct or not. So I'm considering the same example over here where a is equals to 10 and b is equals to 8. So if I apply the XOR method over here, I write a XOR b and run the program. So let's see what output we get. Yes, we get 2 over here. That means the method that we have learned is correct and it works in this way. Right guys, so this is how AND or an XOR works in a bitwise operators. Now we will be talking about bitwise left shift operator. Now let's understand what is left shift operator. So to understand our left shift operator over here, I'll be considering an example where our A is equals to 10, whose binary is 1010. Okay. Now what I need to do is if I use a left shift operator, it will add two more zeros to it. The left shift operator shifts the whole value by two zeros by adding two zeros in the end. So you can add as many zeros as you want, doesn't matter how many times. Like if you're shifting it with two zeros, it will shift by two zeros. If you're shifting it with one zeros, you can shift it by one zero. The choice is totally up to you. That it just shifts from the left hand side. From the left hand side, it gives a shift over there. So if I use a left shift operator and shift it by two zeros, so let's see what will I get. I'll get 1010 0 0. And if I put it over here, I'll write 0 0 0 1 0 1. So my 32 plus 8 will become 40. So this should give us 40. Let's give it a try on our Python as well. So I'm considering an example of A is equals to 10 over here. And then I write print 10 left shift 2 and run it. It gives me 40. That means our left shift bitwise operator is working clearly, and this is the method to shift it. Let's consider another example over here. So I'm considering an example of 15 over here. We know that 15 is equals to 1 1 1 1. If I'll shift it by 1 over here, let's see what do we get. We get 1 1 1 1 0. When I get 0 1 1 1 1 over here, 16 plus 4 is 20, 20 plus 8 is 28, plus 2 is 30. So it should give me 30. By shifting it with 1 0, it should give me 30. Let's see if it works or not. So when I write A is equals to 15 over here and I shift 15 by 1 0, then yes, I get the output 30. That means it is working properly, and this is how the method of left shift operator works. Now let's understand what is right shift bitwise operator. So guys, talking about right shift bitwise operator, so what right shift does, right shift removes the last two bits from the string. Let's have a look on how it can be done. For example, I'm considering the case of 15 over here. So if I use a right shift bitwise to it, so it will be 15. For the right shift, I will be using the arrows that are pointing towards the right, and I'll be writing the value that by how many bits I want to shift it, how many bits I basically want to remove from the end. So from 1 1 1 1, if we remove the two bits from it, we are left with 1 1. So if I write 1 1 over here, I get 3. So if we apply the right shift bitwise operator on 15, the value that we will receive will be 3. Let's have a look on how it can be done. So here I have created a variable A whose value is 15. I'll be applying the right shift operator over here. So 15, arrows pointing towards right. I'll be shifting it by two values. Let's run and see what output do I get. I get 3 over here, which is correct. That our method that we have applied to learn right shift operator is correct. Let's consider another example over here. So let's say I have taken a binary string for number 8, that is 1000. What I want to do, I want to shift it by 1. I want to remove 10 from the end. So I'll be using a right shift operator on it. So what I will be doing, I'll be using 8 right shift by 1 because I want to remove one bit from the end. I'll be using right shift symbol over here and using 1 over here. So if I remove 1, it gives me 100, which gives me 4. So if I remove 1 bit from the end of the 8, I'll receive 4. Let's have a look how it can be done on Python. See, here I'm considering the case of 8 over here, that a is equals to 8, and here we will be removing one bit from it, and here we will be removing 1 bit from it. So I'll be writing 8 right shift bitwise operator, and I'll be shifting it by one value. That means I'll be destroying one value, and if I run it, it gives me 4. So this is how, guys, the right shift and the left shift operators are used in bitwise operators. So I hope you guys have no doubts and no question in the bitwise operators. In the bitwise operators, we covered AND operator, OR operator, XOR operator, left shift operator, and right shift operator. So in our next session, we will be talking about membership operators. Those will be the last operators, and then we will be moving ahead with the problem solving part of this module. So stay connected, guys, and I'll see you in the next session. Thank you.